Okay, let us start. Okay, the third problem is similar to the previous one, but somewhat different. Here we have a link OA, ACB. The link number ACB is a shaded one. That is a single link. Okay, I can see three edges, but it is a single link. It is a plate type link. Okay, and B is a piston. There is a force acting on ACB link number two. Link number three. The force is F. The F is given, that is 500 Newton. So we need to find out the torque required to stabilize the system or for the static equilibrium, right? OA length is given and AB is also given, that is 250. OA is also 250. Sorry, OA is 250 and AB is 650. 650, right? Respectively. Okay. Now we need to draw the figure. Don't waste time. So let us go to the step one. Step one. Drawing. Draw the system with actual scale. Now, if you come back to this one, the maximum length is 650. Will take 100 millimeter is equal to 1 centimeter. 1 centimeter. You can draw it. The scale. 100 millimeter is equal to 1 centimeter. Because 650 millimeter is there, 6.5 maximum length will be 6.5. So that you can easily draw in a A4 size sheet. So I have taken the scale as 100 millimeter is equal to 1 centimeter. Now I have to start. First, I have to draw an horizontal line. So horizontal line is like this. So I'll erase. I'll make it dotted line. Next, I'll mark a point somewhere here. That is O. And this point is fixed. Correct? And OA, length of OA is 250 millimeter, means 2.5 centimeter. 2.5 centimeter at an angle of 60 degree. So I will take 60 degree line. Later, I'll cut it to 2 centimeter length. 2 centimeter will be somewhere here. Okay, this is A. I cut the length to point A. Correct? Cut the length to point A. The angle is 60 degree. After that, I have a piston. Look at this piston. I need to locate this point. Okay, the piston at a distance of 50 millimeter. So just draw the line at a distance of 50 millimeter. Just draw one more line at a distance of 60 millimeter. Sorry, 50 millimeter. See, I'll draw 50 millimeter line. 50 millimeter means 0.5, correct? 0.5. So I've drawn a 50 millimeter line. Okay, just draw a 50 millimeter line. This is 50 millimeter. 50 millimeter, according to the scale, it is 0.5 centimeter, right? 0.5 centimeter. Okay, this is according to the scale, it is 0.5 centimeter. Don't get confused. Some people will do the mistake here. AB length, you will take it with a scale, okay, that is 2 centimeter. But here, this distance, you will take 50 millimeter. That is wrong. 50 millimeter is nothing but 0.5 centimeter. Okay. After that, now we need to take the length of AB. What is the length of AB, Mr. Avanish? AB length. Mr. Avanish. Avanish, am I audible? Avanish is there? Okay. Nitin Narona? Nitin, am I audible? Where were you last two classes? Nitin, last class I was calling you. You not replied.
Sir, I was there, sir.
Huh?
I was there in the class, sir.
But I have removed you.
Yes, sir.
You not replied. Both the classes. Hmm? Nitin. So after this class, you just scan your notebook and send it to my WhatsApp number. Immediately after this class.
Yes, sir.
Okay. So next is AB length. What is the AB length, Nitin? $650 means 6.5 centimeter. So take the length 6.5 centimeter. $6.5 get the length here. So 6.5 centimeter and cut it here. We'll get a point here B. Okay. Once you cut the length, join this. Okay. So this is AB. Now AB, we have 30-degree line. Both the side we have 30-degree. So take 30-degree line. Because it's an equilateral triangle, right? 30-degree line. And here 30-degree. Here also it is 30-degree. Okay. So 30-degree. So it will intersect at this point. This point is D. Sorry, C, right? C. And you can shade this area. Since it is a single link, it indicates it is a single line. So you can shade it. Okay. Now on point B, you need to draw the piston. Look at this. You can take any width. So this is a piston. The piston is sliding over the surface. Right? This is what the figure. Anything else? Force is there, right? You need to mention the force. So we have a force. At what distance or what angle the force is there? At an angle of 30. Look at this. This is 30 degree. So I need to draw an horizontal line through point C. Horizontal line. Yeah. So after drawing the horizontal line, take 30-degree line. (30°). So this is what the force Q. Q is, sorry, F is 500. Not Q, it is F. 500 Newton. And we need to give the numbers to the links. Link number 1 is here. This is link number 1. Link number 2 is a crank. This is the link number 3. And the piston is link number 4. Okay. So link number 2, link number 3, link number 4. 1, 2, 3, 4. Now you just measure this angle. What will be this angle? You just measure it and write it here, okay? This theta. What is the value of theta here? Can anyone tell me the answer for theta?
degree.
Yes, sir. Yes, repeat. Hello. Can you repeat?
15 degrees, sir.
14
14
degree.
degree.
Huh?
15 degrees, sir.
14.4.
ಸರಿ ಹೇಳ ಎಷ್ಟು
14.
14. ಓಕೆ 14 ಡಿಗ್ರಿ. ಆಕ್ಚುಲಿ 15 ಡಿಗ್ರಿ ಬರಬೇಕು. All of you finish the figure? Okay. So we go to the next slide. Hello. Next, free body diagram.
Sir,
Yes.
AB value.
Huh?
What is the AB length? AB length.
AB length
AB
is,
length.
huh? Hello.
6.5.
What you're asking? I'm not getting. Why do you stop in between?
Sir, in the question,
Huh?
sir, in the question OA and AB, in the question OA and AB length both are same, sir.
OA and AB length?
I think same.
No, not like that. You see read the problem. Length of OA and AB are, actually you can take it as R, not equal, okay? OA and AB are 250 and 650
Okay, sir.
respectively.
Got it. Got it.
Got it? Finished? Hello, finished? Okay, shall we go to the next slide?
Yes, sir.
Okay.
Yes, sir.
Next is free body diagram. You need to draw the free body diagram for each and every link. You need to show the forces, right? This step. We have given a link numbers. Link number one is a fixed link. Number two is a crank AB, and link number three is a ABC. See here, you cannot give a link number three to this one, for this, 15, not like that, because ABC is a single link, correct? That you have discussed in the kinematics of machines. Shaded region will be considered as a single link. And link number 4 is a piston, correct? So next step, first we need to draw free body diagram for the first one, crank. What is the length? What is the length? Reference line at a 60-degree line, 2 centimeter, right? 60-degree line, 2 centimeter. Two centimeter, cut the length. So A, B, correct? Yeah, this is 60-degree line. Now, what are all the forces acting on this link? So we need to find out the torque on this one. I don't know the torque. We need to find out the torque on crank. It is not given in the problem clearly, but torque will be applied on the crank only always. It's asked you to find the required input torque. Input torque means it is on OA. Okay, torque that I have mentioned here, torque T. Now, so free body diagram for AB. Here, point O is connected to the link number 1. There is a force by the link number 1 on link number 2. That is F. I don't know the direction. I don't know the magnitude. That's why zigzag line. This is F1, 2. That is force by link number 1 on link number 2. Next, here link number 2 and 3 is connected at a point B, sorry, A. So the force acting on A, F, what is this force? Can anyone tell? Mohit? Mohit? Yes, Mohit. Mohit is not there? Okay, Siddharth. Siddharth Shekhar. Siddharth Shekhar.
Sir,
Tell me the force acting at a point B on link number 2.
yes,
F? Hello? Siddharth? Siddharth, I'm not audible. Shall I remove you, Siddharth?
sir, three,
F?
three,
What, F3? Only F3?
F3 two.
F3, 2. Very good.
Yes, sir.
So, force by link number 3 on link number 2. Correct? F3, 2. Next. That is the first link. And we have a torque, unknown torque. I don't know the torque, but I have to mention it, T. This is the free body diagram of the link number 1. Sorry, link number 2. Next, link number 3. Link number 3. See. So first you take the reference line. Okay. So mark a point. This point is B. What is the angle? 15 degree, right? Or 14? Okay, 14 degree. Theta. 14 degree. And what is the length? 6 centimeter, right? Or 6.5. And take 30 degree, both the side. You take 2 lines. 30 degree, 30 degree. And shade this. This is BC. So we have one more horizontal line and we have a force. What is that force? F at an angle of 30 degree. F is 500. Now what are the forces acting? Where is point B? Point B, we have a force that is F32 on link number 2 and F23. This is F23. Here we have one more force that is at point, sorry, OA. This is A. Correct? Okay. This is A. This is B. So at this point, we have one more force. That is unknown F43. Link number 4 on link number 3. Force by link number 4 on link number 3 because point B is connected to the link number 4. So how many forces are there? 3 forces. One is known both in direction as well as magnitude, but the remaining 2 is unknown. Next, link number 4, piston. I have a piston. Okay, this point is B, and this is link number 4. We have a force, upward force. One force is upward always. If there is a piston, there will be upward force in this like direction. So that is, I'll show it. This is one upward force, that is F14 due to link number 1 on 4, that is fixed link 1. And we have another force by link number 3, that is zigzag here in the link number 3. Here also it will be zigzag because I don't know the direction and magnitude. F4 3 here, it is F34. This is what the free body diagram. Is there any doubt? Any doubt in this problem? It is very, very simple problem, and it is asked many times in the previous question papers. You can see the question paper. If you open the question paper, you can see many times he has asked this question, and it is a solved problem in a SS Ratan textbook. Okay. Now, all of you copied this. Wait fast. We have another 25 minutes. All of you copied this.
Yes, sir.
Any doubt? Any doubt? Any doubt? No doubt. Initially, first we take OA. OA, both the two forces will be acting at two different points, O and A. O is connected to link number 1. That's why the force is F12. I don't know the direction as well as magnitude. Next point A, we have F32 because A is a common point on link number 2 and 3. That's why the force is F32. And unknown direction, unknown magnitude. If you come to the link number 3, we have opposite to the F32, we have F23 on link number 3. That is F23. That also I don't know the magnitude as well as direction. Next, F I know, I have shown it as 500 Newton. If you come to the point B is connected to the link number 4. That's why the corresponding force is F43 due to link number 4 on link number 3. Don't get confused while writing the name of the force. Okay, and this is also unknown direction as well as magnitude. If you come to the link number 4, that is a piston, first one you need to draw or you need to show the force, upward force, the reaction force by the link number 1 or a cylinder or a fixed link. That is F14. And one more force is there, that is due to link number 3, F43, opposite to the F43, we have F34, and that is unknown direction as well as magnitude. That's all. Now, how to solve this problem? Can anyone tell? How to start to solve the problem? Because link number 2 is having two unknown, one torque unknown. You cannot select it. You come to the link number 3. Link number 3, we have only one force with known magnitude as well as known direction, but remaining two are unknown, both in magnitude as well as direction. So you cannot draw the force polygon or you cannot find out, right? Because a link with or a body with a 3-force member, how to state the equilibrium? These 3 forces must be concurrent. That is the first condition. Second condition, summation of all the forces must be equal to 0. But you cannot take this summation of all the forces must be equal to 0 because we have two unknowns. You cannot take this. But is it possible to take the concurrent point for 3 forces? No, because I have only one force known, but the remaining two forces, I don't know the direction. You cannot find out the point of concurrency. Is it? Link number 3. See, you analyze the problem in this step. Otherwise, you cannot solve the problem. Which link is to be taken to solve the problem, to find out the unknown? So you cannot take the third link also, because third link is a member of 3-force member. But 3-force member, how to state the equilibrium, static equilibrium? Point of concurrency. Is it possible to find out the point of concurrency in this case? No, because two forces are unknown direction. So, and you cannot take the force polygon also, because we have only one known and remaining two are unknown. You cannot draw the force polygon. So you can forget link number 3 also. The rest one is link number 3. Sorry, link number 4, piston. You come to the piston. Piston is a 2-force member. What is the statement for the static equilibrium of a 2-force member? So a body with a 2-force member, one force direction is known, that is F. One force is opposite exactly, the direction of upward. Automatically, the other force is also in the same direction, but it is opposite. But here I don't know the direction, but according to the statement of static equilibrium, what it says, if the body is a member of 2 forces, then these 2 forces are equal and opposite. So you can find out the direction of F34. What is the direction of F34? It is vertical downward, not a zigzag. We have shown it as a zigzag, but it is actually exactly downward. If F34 is downward, automatically F43 is upward. Correct? So we'll know the direction of F43 as well as F34. So if you come to the link number 3, if you know the direction of F43, you can extend it in the upward direction. It will intersect F at a point somewhere here. This will be the point of concurrency, right? Automatically the third force F23 is also intersecting on the same point. Look at this. This is what the point of concurrency. All 3 forces are meeting at a point. So you will have a direction of this one as well as this one. If you know the direction of these 3 forces, you can draw the force polygon. You can find out the value of F43 as well as F23. Correct? Force polygon. If you know the value of F43, you can find out the value of F34. And if you know the value of F23, you can find out the value of F32. It is equal and opposite. If you know the value of F32, you can find out the value of F12, because it is equal and opposite. So if you know the value of these 2 forces, you can find out the couple, that is C, and this couple is opposite to the T. So, and equal and opposite, that is C is equal to T. You can easily solve the problem. Understood? So I have explained how to solve this problem. Shall we start? Hello? A small clue is there on link number 4. Link number 4 is the 2-force member. 2-force member for static equilibrium. What is the condition? Equal and opposite. So F34 will be having exactly downward, not zigzag, according to the given problem, right? According to the static equilibrium statement. Shall we solve the problem? Open your mouth. Hey, Matadra.
Yes, sir.
Okay.
Yes, sir.
So how to solve this problem? From which link we have to start the problem?
Link number 4.
Yes, very good. Link number 4. Why? Because it is a 2-force member. It is a 2-force member. This is F43, correct? F43. Okay. This is F34. Okay. So consider, write down. Next step. Finding unknowns. Step 3. Finding unknowns. Okay. Bekadre note barkoli. If you want, link number 2 is having 2 unknown forces. You cannot solve the problem by link number 2. Link number 3 is having only 1 known force, 2 unknown force. You cannot consider for the solving problem. Link number 2, consider link number 4, right? Link number 4. Why the link number 4 is considered? Because it is a 2 force member. So link 4 is a 2 force member. 2 force member. 2 force member. So what is the condition for a 2 force member? ಬೇಕಾದ್ರೆ ಫ್ರೀ ಹ್ಯಾಂಡ್ ಸ್ಕೆಚ್ ಡ್ರಾ ಮಾಡ್ಕೊಳ್ಬಹುದು. You can draw the free hand sketch, no problem. Point B, link number 4. One is upward, that is F14. Automatically, the downward force, what is the downward force? F. What is that? F34. F34 is downward. Why? Because according to the statement of static equilibrium of 2 force member, both the forces are both F34 and F14 are equal and opposite. Therefore, F34 is equal to F14, right? F34 is downward. F34 is downward. I don't know the magnitude, but I know the direction. F34 is downward. Correct? One direction I know, direction of F34. Shall we go to the next slide? Copied? Free hand sketch, you can draw the free hand sketch. No need to worry about that, okay? So what is the direction of F34? F34 is downward, exactly downward, vertical. Correct? Okay. Next. Finished?
Yes, sir.
Shall we go to the next slide? What we have to do next? Next, with this, you cannot, we know the direction, but we don't know the magnitude. You cannot find out the magnitude by this link, right? We can find out only the direction of F34. That's all. Next step. So consider link 3. Now the link 3. Consider link 3. ನಿತೇಶ್ ಇವತ್ತು 3rd ಅವರು ಜಯಶ್ರೀ ಮೇಡಮ್ ಇದೆ, ಅದು ತಗೊಳ್ತಾ ಕೇಳಿ ನೋಡ್ತೀರಾ? ಫೋನ್ ನಂಬರ್ ಇಲ್ಲ ಅಂತ ರಜೆಲಿದ್ದೀರಾ? ನೋಡ್ತೀನಿ, ಕ್ಲಾಸ್ ಮುಗಿಸ್ಮೇಲೆ ಕೇಳ್ತೀನಿ. ಆಯ್ತು, ಕೇಳ್ತೀನಿ, ಅವ್ರಿಗೆ ಗೊತ್ತು, ನಂಗೆ ಬರ್ತಿದ್ರು ಅವ್ರು ಇಲ್ಲಿ. ಆಯ್ತು, ಕೇಳ್ತೀನಿ. ಓಕೆ ನಿತೇಶ್. Okay. So consider link number 3. Now, what is the link number 3 here? Link number 3, we have F43. Always F43 is equal to F34, right? F34. And what is the direction of F43? F34 is downward, and F43 will be always upward. Correct? We know the direction of F43. So write down. Link number 3, we have F43 is equal to F34. What is the direction? This is upward. Which one? Upward. So F43 is upward, F34 is downward. It's already given the previous step, right? So you can write down it is downward previous step. We know F34 is downward in the previous step, right? Yeah, upward. So F43 is upward. Now we can draw the figure of third link. So third link, first you take the reference line. So you need to draw the actual scale, okay, here. Actual scale. So 15 degree, 14 degree, 14 degree 60 length. 14 degree 60 length and 30 degree line. 30 degree line. Correct? A, B, C. A, B, C. So I have one more force at point C, that is F at what angle? At what angle? 30 degree line. Says F. So this is the shaded region. 30 degree, take 30 degree. Do with actual scale, please. Otherwise, you cannot solve the problem. This step is very, very important. If you draw with actual scale, then only you can solve it. You'll get the exact answer. 30 degree. Sorry, not 30 degree. That is theta. 14 degree. Another 10 minutes. Do it fast. Please do it fast. I have to finish this step at least. Copied? Hello? ಬೇಕಾದ್ರೆ ನೀವು ಈ ಫಿಗರ್ ಅಲ್ಲಿ ಡ್ರಾ ಮಾಡಬಹುದು, ನೋ ಪ್ರಾಬ್ಲಮ್. ಇಲ್ಲೇ ಕಡೆ ತೋರಿಸಬಹುದು, ಬಟ್ ಇಲ್ಲಿ ತೋರಿಸಿದ್ರೆ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ ಪುನಃ. ಅದಕ್ಕೋಸ್ಕರ ಪುನಃ ಡ್ರಾ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಕಾಪಿಡ್? 30 ಡಿಗ್ರಿ 30 ಡಿಗ್ರಿ ಪಾಯಿಂಟ್ ಸಿಗುತ್ತಾ? ಪಾಯಿಂಟ್ ಸಿ ಅಲ್ಲಿ ಎಫ್ ತೋರಿಸಬೇಕು. ಎಫ್ ಇಸ್ 500. Now what is the direction of F43? Now F43 is upward. It is given here, upward F43. So F43 upward. I'll show it as upward force. This is F43. F43. Now link 3, write down below this. Link 3 is a 3-force member. 3-force member. What is the condition for? According to static equilibrium, what is the condition? So one more force is that is F23, correct? F23. This is link number 3. F23. So F43 and F43, F and F23 are concurrent, right? So point of concurrency, how to find out the point of concurrency? You need to extend F43. See, I'm going to extend it. Extend F43. So we'll get, and it will intersect which force? AF, second force. Because I cannot extend F23 unknown direction, but I can extend. So this is what the point of concurrency, POC, where it intersect. Therefore write down below this. It's better to write the steps, otherwise you'll get confused. So extend F43 towards F and intersect at POC. join A and POC. A and POC. See, this is a point of concurrency. These two forces are intersecting at this point. Third force also meets at this point only, right? So how to do that? You just join POC with A. So this is what the point of or line of action of, this is called as line of action of F23. F23, line of action of F23. Why? Because the third force also intersect at the same point. How to intersect it? You need to extend or you need to join POC with the point of action of F23. So A. If you join this, this is what the line of action of, what is this? Line of action of action LOA, line of action of, what is this? F23. What is this? This is the line of action of LOA, line of action of what? Which force? F43. So this is a POC, point of concurrency. Now we know the direction of F23, we know the direction of F43, and we know the direction of F. Now we can draw the force polygon to find out the unknown. All of you copied? Hello? Same as the previous problem, right? Copied? First end ಮಾಡಬೇಕು F43 ನ extend ಮಾಡಬೇಕು towards F. We'll get point POC, that is point of concurrency. What is the meaning of point of concurrency? Three body of force of two members. One force, this is F43, and another one is F. Okay, this is F, correct? F is 500. F. If these two forces are meeting at a point POC, okay, this is POC. The third force, I don't know the direction. Okay, what is that? F23. So F23 also has to meet at the same point. That's why I have drawn this F23 line. Join the point. Which point? Line of action. This is actually point A. Point A to POC. A to join A to POC. That's all. That is the line of action of F23. Write it as line of action of F43. LOA is nothing but what? Line of action. Line of action. Copied? Hello? ಆಯ್ತನ್ರಾ? ಯಾರು ಮಾತಾಡಲ್ಲ ಮಾರ್ರೆ, ಏನ್ ಕಥೆ ಅಂತ ಗೊತ್ತಾಗಲ್ಲ. ಮುಗಿಸಿದಿರಾ ಇಲ್ಲವೋ? ಹಲೋ? ಬೇಕಾದ್ರೆ ಸೈಡ್ ಅಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ, ಇದನ್ನ ಬರ್ಕೊಳ್ಳಿ. ಬೇಕಾದ್ರೆ ನಾನು ಹೇಳಿದ್ದೀನಿ ಆಗ್ಲೇ, ಬೇಕಾದ್ರೆ ನೀವು ಬರ್ಕೊಳ್ಳಿ. ಯಾಕೆ ನಾನು ಪಾಯಿಂಟ್ ಆಫ್ ಕನ್ಕರೆನ್ಸಿ ಪಾಯಿಂಟ್ ಮಾಡ್ತೀನಿ ಅಂತ? ಬಿಕಾಸ್ ಇಫ್ ದ ಬಾಡಿ ಇಸ್ 3 force member, point of concurrency will be same for all 3 forces and summation of all the forces must be equal to 0. ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಇಲ್ಲಿ ನಮ್ಗೆ ಏನ್ ಸಿಗುತ್ತೆ? F23 ಡೈರೆಕ್ಷನ್ ಸಿಗುತ್ತೆ, right? In this figure we will get F23 direction. F23 direction is nothing but line of action of F23. ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಈಗ what is the meaning of this figure? F23 is acting like this, not zigzag. This is F23. Is zigzag alla, aita? Gottaitala? Zigzag, you can remove it. Okay? Finish aitala? Next step, force polygon. Write down. Draw the force polygon. Polygon for what? For link 3. First force ಏನಇದೆ? F500. Scale 100 ನ್ಯೂಟನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಸೆಂಟಿಮೀಟರ್ ತಗೊಳ್ತೀನಿ ನಾನು. ಫಸ್ಟ್ ಏನು ಎಫ್ ಇದೆ. ಸೊ ಎಫ್ ಅಂತಂದ್ರೆ ಓಕೆ, ಇಲ್ಲಿ ನೋಡಿ ತಗೊಳ್ತೀನಿ. ಎಫ್ ಒಂದು ಪಾಯಿಂಟ್ ಮಾರ್ಕ್ ಮಾಡ್ಕೊಳ್ತೀನಿ. ಇಲ್ಲಿ ಒಂದು ರೆಫರೆನ್ಸ್ ಲೈನ್ ತಗೊಳ್ತೀನಿ ನೋಡಿ, 0 ಡಿಗ್ರಿ ಲೈನ್. ಇಲ್ಲಿಗೆ ನಾನು 30 ಡಿಗ್ರಿ ತಗೊಳ್ಬೇಕಲ್ವಾ, ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ 30 ಡಿಗ್ರಿ. F is acting at 30 degree, right? So from this point I'll take F. Okay, what is the length of F? 500. 500 means 5 centimeter. Take 5 centimeter length. Five centimeter length. Okay, F is equal to 500 Newton. ಸರಿ ಅಲ್ಲ? ನೆಕ್ಸ್ಟ್ ಏನು, ಎರಡನೇ ಫೋರ್ಸ್ ಯಾವುದು? F43 ವರ್ಟಿಕಲ್ ಅಂತ ಹೇಳಿದಾನೆ. ಎ, ದಿಸ್ ಇಸ್ ಪಾಯಿಂಟ್ ಎ. ಓಕೆ, ವರ್ಟಿಕಲ್ ಅಂತಂದ್ರೆ ಐ ಡ್ರಾ ವರ್ಟಿಕಲ್ ಲೈನ್. ಲುಕ್ ಅಟ್ ದಿಸ್, ಜಸ್ಟ್ ಐ ಡ್ರಾ ವರ್ಟಿಕಲ್ ಲೈನ್. ನನಗೆ ಗೊತ್ತಿಲ್ಲ ಮೇಲಿದೆಯೋ ಅಥವಾ ಕೆಳಗಿದೆ ಅಂತ. ವರ್ಟಿಕಲ್ ಅಂತಿದೆ, ಮೇಲಿದೆ ಅಲ್ವಾ? ಇಲ್ಲಿಂದ ಮೇಲ್ ತಗೊಳ್ತೀನಿ. ಐ ಡೋಂಟ್ ನೋ ದ ಲೆಂತ್. ಡು ಯು ನೋ ದ ಲೆಂತ್ ಆಫ್ ದಿಸ್ ಒನ್? ಡು ಯು ನೋ ದ ಲೆಂತ್? ನೋ, ಕರೆಕ್ಟ್. ಬೇಗ ಬರ್ಕೊಳ್ಬೇಕು. ಆಕಾಶ್ ಅಡವಿ ಬಾವಿ. ಓಕೆ, ಐ ಡೋಂಟ್ ನೋ ದ ಲೆಂತ್. ದಿಸ್ ಇಸ್ F43, ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಬಟ್ ವರ್ಟಿಕಲ್ ಅಂತ ಗೊತ್ತಿದೆ ನನಗೆ ಲೆಂತ್ ಗೊತ್ತಿಲ್ಲ ಅದ್ರದ್ದು ಅಲ್ವಾ? ಕರೆಕ್ಟ್ ಅಲ್ವಾ? F43, ಐ ಡೋಂಟ್ ನೋ ದ ಲೆಂತ್, ಜಸ್ಟ್ ಲೀವ್ ಇಟ್. ನೆಕ್ಸ್ಟ್ F23 ಅಲ್ಲಿದೆ. F23 ಇಸ್ ದ ಲೈನ್ ಆಫ್ ಆಕ್ಷನ್ ಆಫ್ ದಿಸ್ ಫೋರ್ಸ್, ದಿಸ್ ಒನ್. ಜಸ್ಟ್ ಏನ್ ಮಾಡಿ ಅಂತಂದ್ರೆ ನಿಮ್ಗೆ ಇದ್ರದ್ದು ಆಂಗಲ್ ಪಾಯಿಂಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಯಾವ ಪಾಯಿಂಟ್ ಇಂದ? ಸಿ ದಿಸ್ ಪಾಯಿಂಟ್, ರೆಫರೆನ್ಸ್ ಲೈನ್ ತಗೊಳ್ಳಿ. ಈ ಆಂಗಲ್ ಥೀಟಾ 5 ಅಂತ ತಗೊಳ್ತೀನಿ ನಾನು. ಇಲ್ಲಿ 5 ಮೆಜರ್ ಮಾಡಿ. what is the angle of 5? 5 ಆಂಗಲ್ ಎಷ್ಟಿದೆ ನೋಡಿ. Can anyone measure the angle 5? ಅಥವಾ ಇಲ್ಲೂ ಕೂಡ ಮೆಜರ್ ಮಾಡಬಹುದು. ಇಲ್ಲಿಂದ ರೆಫರೆನ್ಸ್ ಲೈನ್ ತಗೊಂಡು ಇದು ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ 5, ಕರೆಕ್ಟ್? ಎರಡು ಸೇಮ್ ಆಲ್ಟರ್ನೇಟ್ ಆಂಗಲ್ ಅಲ್ವಾ? 5. what is the angle 5? Can anyone tell? ಬೇಗ ಬಿಡ್ಬೇಕಂದ್ರೆ ಬೇಗ ಆನ್ಸರ್ ಹೇಳ್ಬೇಕು. ಆಯ್ತು, ಟೈಮ್ ಆಯ್ತು, ಬೇಗ ಡು ಇಟ್ ಫಾಸ್ಟ್. ಆಂಗಲ್ 5 ಯಾರಾದ್ರೂ ಹೇಳ್ರೋ?
23 degree.
23 ಡಿಗ್ರಿ ಅಲ್ಲ? 23 ಡಿಗ್ರಿ. ಇಲ್ಲಿ ಕೂಡ 23 ಡಿಗ್ರಿ ಅಂತ ಹೇಳಿದಾನ ನಮ್ಮ ಋತ್ವಿಕ್ ಅಲ್ವಾ? 23 ಡಿಗ್ರಿ. ಇಲ್ಲಿ ಏನ್ ಮಾಡಿ ಗೊತ್ತಾ, ಈ ಪಾಯಿಂಟ್ ಇಂದ 23 ಡಿಗ್ರಿ ತಗೊಳ್ಳಿ. ಒಂದು ರೆಫರೆನ್ಸ್ ಲೈನ್ ಇದೆ, ನಾನು 23 ಡಿಗ್ರಿ ತಗೊಳ್ತೀನಿ ನೋಡಿ. ಈ ಪಾಯಿಂಟ್ ಇಂದ 23 ಡಿಗ್ರಿ ತಗೊಳ್ಳಿ. ಇದು ಹಾರಿಜಾಂಟಲ್ ಲೈನ್. ಈಗ 23 ಡಿಗ್ರಿ ತಗೊಳ್ಬೇಕಂತ ಹೇಳ್ತಿದ್ದಾನೆ ಮಿಸ್ಟರ್ ಋತ್ವಿಕ್. ಸೊ ಇಲ್ಲಿ 23 ಡಿಗ್ರಿ ತಗೊಳ್ತೀನಿ ನೋಡಿ. ಕಟ್ ಮಾಡ್ತೀನಿ ಲೈನ್ ಅನ್ನ. ಇದು ಕಟ್ ಆಗೋ ತನಕ ಡ್ರಾ ಮಾಡಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ 23, 5, ಕರೆಕ್ಟ್ ಅಲ್ಲ? ದಿಸ್ ಇಸ್ ಆಂಗಲ್ 5, 23, ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ದಿ ಎಕ್ಸಾಕ್ಟ್ ಫೋರ್ಸ್. ಇಲ್ಲಿ ನೋಡಿ, ಇದು this force is in this direction, this force is upward, and this will be always towards right. This is what F23 alla? F23. Now this point is B, correct alla? Now you can find out the answers. F43 is equal to AB length into scale. ಎಷ್ಟು ಲೆಂತ್ ಇದೆ ನೋಡಿ ಹೇಳಿ. ಸಿಮಿಲರ್ಲಿ F23 is equal to OB into scale. ಆನ್ಸರ್ ಹೇಳಿ. ಸ್ಕೇಲ್ ಎಷ್ಟಿದೆ? 100. ಸ್ಕೇಲ್ ಇಲ್ಲಿ ಕೂಡ 100. ಲೆಂತ್ ಹೇಳಿದ್ರೆ ಆಯ್ತು. ನೀವು ಲೆಂತ್ ಹೇಳಿದ್ರೆ ಆನ್ಸರ್ ಸಿಗುತ್ತೆ ನಿಮ್ಗೆ. ಬೇಗ ಬೇಗ ಮುಗಿಸ್ಬೇಕು. ಆಯ್ತು 10:05. ನೆಕ್ಸ್ಟ್ ಅವರ್ ಏನಿದೆ? ನೆಕ್ಸ್ಟ್ ಅವರ್ ಏನಿದ್ದೀರಾ?
DME.
DME.
Yes, sir.
ಓಕೆ, ಥರ್ಡ್ ಅವರ್ ನಾನೇ ತಗೊಳ್ತೀನಿ. ಥರ್ಡ್ ಅವರ್ ಇವ್ರು ಸ್ವರೂಪ್ ಇಲ್ಲ, ಆಯ್ತಾ? MEC ಇದೆಲ್ಲ. ಥರ್ಡ್ ಅವರ್ ಅನುದೀಪ್ ಮಧ್ಯಾಹ್ನ ತಗೊಳ್ತಾರೆ. ಫಸ್ಟ್ ಅವರ್ ಟರ್ಬೋ ಮಷಿನ್ ಬದಲಿಗೆ ನಾನು ಥರ್ಡ್ ಅವರ್ ತಗೊಳ್ತೀನಿ MEC ಬದಲಿಗೆ. ಓಕೆ, ನಾವು ಟೆಲ್ ಮಿ ದ ಆನ್ಸರ್ ಫಾರ್ AB ಲೆಂತ್ ಎಷ್ಟಿದೆ? ಇಲ್ಲಿ ಯಾಕೆ 23 ಡಿಗ್ರಿ ತಗೊಂಡ್ರೆ ಗೊತ್ತಾಯ್ತಲ್ಲ. ಇದು ಲೈನ್ ಆಫ್ ಆಕ್ಷನ್ ಆಫ್ F23 23 ಡಿಗ್ರಿ ಇದೆ ರೆಫರೆನ್ಸ್ ಲೈನ್ ಇಂದ, ಅದಕ್ಕೋಸ್ಕರ. ಕ್ಯಾನ್ ಯು ಟೆಲ್ ಮಿ ದ ಆನ್ಸರ್ ಫಾರ್ AB? ಬೇಗ ಹೇಳ್ರೋ.
Seven. 0.7.
ಅಷ್ಟೇನಾ?
0.8.
ಯಾವುದು? AB ಲೆಂತ್ ಪಾಯಿಂಟ್ ಎಷ್ಟಿದೆ? ಸರಿದೆ ಹೇಳಿ ಆನ್ಸರ್.
0.8.
0.8. ಓಕೆ, 0.8. ವೆರಿ ಗುಡ್. ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲ ಇದು. ಆನ್ಸರ್ ಎಷ್ಟು ಬಂತು? OB ಎಷ್ಟು ಬಂತು ನೋಡಿ. ಒಬ್ರು ಆನ್ಸರ್ ಹೇಳಿ, ಒಬ್ರು OB ಹೇಳಿ.
4.6.
4.6. ಎಷ್ಟು ಬಂತು? 80 ನ್ಯೂಟನ್. ಕರೆಕ್ಟ್ ಅಲ್ಲ ಇದು?
$460.
80 ನ್ಯೂಟನ್. ಇದು F43 ಅಪ್ವರ್ಡ್. ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಅಪ್ವರ್ಡ್ ಅಂತ ಬರಿಬೇಕು. ಅಪ್ವರ್ಡ್. ಇಲ್ಲಿ ಎಷ್ಟು ಬಂತು? 46 ಅಲ್ಲ? 460 ನ್ಯೂಟನ್. F23 ಇದು ಡೈರೆಕ್ಷನ್ ಯಾವುದು? ಟುವರ್ಡ್ಸ್ ರೈಟ್ ಅಲ್ಲ? ಟುವರ್ಡ್ಸ್ ರೈಟ್. ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಮಿಕ್ಕಿದ್ ಮಾಡ್ಬೋದು ನೋಡಿ. ಈಗ ಈಸಿಯಾಗಿ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ಬೋದು ಅಲ್ವಾ? ಈಗೇನ್ ಬೇಕು? ಈಗ F23 ಡೈರೆಕ್ಷನ್ ಸಿಕ್ತು. If you know the value of F23, look at this. If you know the value of F23, we can find out the value of F32. F32 is equal to F23, and it is opposite. Here F12 is equal and opposite to F32. You know the value of these two forces. Then you can find out the value of couple. Couple will be C is equal to F32 into perpendicular distance. Perpendicular distance find ಮಾಡ್ಕೊಳ್ಳಿ ಅಲ್ವಾ? ಮತ್ತೆ ಮಾಡುವ, ಆಯ್ತಾ? ಓಕೆ. Okay, you can leave. Take an attendance, no problem.